Welcome to aminacademy.com. In material science and engineering, let us discuss about the structure of crystalline solids. Solid materials may be classified according to the regularity with which atoms or ions are arranged with respect to one another. A crystalline material is one in which the atoms are situated in a repeating or periodic array over large atomic distances. That is, long range order exists such that upon solidification, the atoms will position themselves in the repetitive three-dimensional pattern in which each atom is bonded to its nearest neighbor atoms. All metals, many ceramic materials, and certain polymers form crystalline structure under normal solidification conditions. For those that do not crystallize, this long-range atomic order is absent. These non-crystalline or amorphous materials are discussed later. Now, let us discuss about crystalline structure in detail. What is crystalline structure? Any structure held together by atoms, ions, molecules arranged in a highly ordered three-dimensional arrangement is crystalline structure. This is a basic definition. Crystal structures can be thought of as the highest level of ordering that can exist in a solid material. These arrangements can be referred to as the crystal lattice structure. It consists of a definable chemical composition and ordered structure at the microscopic level, creating three-dimensional materials. Often, the 3D geometric shape of the crystal lattice will dictate the form of the crystal that the human eye. An example of this is in the case of NaCl, normal table salt, where the ionic bonds between sodium and chloride ions join to make isometric crystalline lattice structure at the microscopic level, collectively making the minerals to the human eye appear isometric in shape, that is cube shaped. Therefore, the shape of the crystal structure at the microscopic level will often influence the overall 3D shape of the material, which we see without a microscope. An example being minerals such that the halite, also table salt it is. Next, we'll discuss about what are crystalline solids. Here, solids featuring highly ordered arrangements of their particles like atoms, ions, and molecules in microscopic structure are called crystalline solids. These ordered microscopic structures make up a lattice that accounts for the structure of the solids at any given point. Now let us discuss what is unit cell. The atomic order in crystalline solids indicates that small group of atoms form a repetitive pattern. This in describing crystal structure. It is often convenient to subdivide the structure into small repeat entities called unit cell. Unit cell for most crystal structure are parallelepipeds or prisms having three sets of parallel faces. One is drawn within the aggregate of sphere. Now, in an ordered arrangements of atoms, ions, and molecules described in a crystalline material is termed as a crystal structure. Ordered structures happen where the nature of particles shape up in a pattern that is symmetrical with repeats with the principal direction of matter in three-dimensional shape. A unit cell mirrors the structure and symmetry of the whole crystal that is created by the unit cell's repetitive translation with its principal axis. The principal axis, lengths, and the angles of the unit cell are known as lattice constant. They are known as cell parameters or lattice parameters. The crystal's properties of symmetry are defined by the space groups concept. The structure and symmetry of crystals play a vital role in defining multiple physical properties like cleavage, optical transparency, and electronic band structure. That means the structure of symmetry of crystals play a vital role to that definite property of the materials like cleavage, optical transparency, and electronic band structure. The unit cell is said to be the smallest repeating unit of the crystal lattice in the living organism, which is also said to be the building block of the crystals. That is how life started to exist on Earth. Atoms are arranged in a three-dimensional symmetry within the crystalline structure. A crystal structure is defined as the arrangements of particles in a unit cell in terms of the geometry. The unit cell's geometry is known as a parallelepiped. It provides six lattice parameters marked as the cell edges, length, and their angles. The particles' positions in the unit cell is shown by fractional coordinates. They are measured by the reference points with the edges of the cells. It is important to report the coordinates of particles of the smallest asymmetric subset. Unit cell. Unit cells other particles are created by the symmetry operation which describes the unit cell's symmetry. The collection of unit cell symmetry operation is defined as the crystal structure space group. The group of atoms of the crystal structure is same, the basics. They are stationed around each and every lattice point. There are three types of unit cell present in nature: primitive cubic, body-centered cubic, and face-centered cubic. Here, primitive cubic unit cells. This is a primitive cubic unit cells. It means if you look at the primitive cubic unit cell, you will find out that only at the corners, you are going to find the atoms. Every single atom which is present in the unit cell is shared with the other adjacent cells, meaning that each unit cell shares its atoms with 8 other primitive cubic unit cells. Such a particular unit cell contains only 1/8 of an atom. On the other hand, 4 unit cells are present in the same layer, and there are 2 layers. The upper and lower layer makes a particular unit cell be 1/8 of the atoms that is present inside it. The total number of atoms present in the single primitive cubic unit cell can be counted by taking 8 atoms present in the corner. Thus, we can say 1/8 into 8 equal to 1 atom. Next is body-centered cubic unit cell. This is a body-centered cubic unit. That means the BCC, body-centered cubic unit cell, is almost the same as a simple cubic unit cell, meaning it has 8 atoms present in each corner of the cube and 1 atom in the center of the cube. That is BCC, that is body-centered cubic, has an open structure. The atom which is present at the center solely belongs to the unit cell in which it's present. Look at here. To find the number of atoms present in BCC, you need to consider 2 things. First, 8 corners will make 1/8 per corner atoms, that is 8 into 1/8, that is 1 atom. 1 atom present at the center of the body equal to 1 atom. Thus, the body-centered cubic unit cell has 2 atoms. Face-centered, because this is in body center, one atom is at center and 8 into 1/8 of atoms, considering 8 corners together. So there are body-centered cubic unit cell has 2 atoms. Face-centered cubic unit cell. The face-centered cubic unit cell is the most densely populated unit cell. In addition to this, at the center of the cube space, you will find out one atom. These face-centered atoms are shared between two adjacent unit cells, and only half of the each atom is part of the what to find the number of atoms present in FCC, face-centered cubic crystal. You need to know this in the first place. There are eight corner and eight corners and 18 per corner atoms. That is 8 into 18, 8 into 1 over 18. Sorry, 8 into 1 over 8 per corner atoms. That is 8 into 1 over 8 equals 1 atom. 6 face-centered atoms have 1 over 2 atoms per unit cell, that is 3 atoms. Thus, we have 4 atoms in a face-centered cubic unit cell. Classification of crystalline structure by symmetry. The property that is used to define crystal structure is in its symmetry only. When some symmetry operation are performed on the crystalline lattice, it remains unchanged. All the crystals consist of the translational symmetry in 3 types, but it's possible that some contain other elements of symmetry. Lattice system. What is lattice system? When crystal structures are grouped by the axial system, which is used to define their lattice, it is known as the lattice system. Each lattice system has set of axes that are arranged geometrically. All the crystal comes under the 7 lattice system. They may seem similar, but they are not the same as the 7 crystal system. By summary, we can say this. By summary, we can say that crystalline solids describes the difference in atomic molecular structure between crystalline and non-crystalline material. How to understand unit cells like face-centered, body-centered, and other system of crystalline structure as well. Solid materials may be classified according to the regularity with which atoms or ions are arranged with respect to one another. A crystalline material is one in which the atoms are situated in a repeating or periodic array over large atomic distances, that is, long range order exists. So far we discussed about material science and engineering. We discussed about a structure of crystalline solids and its different arrangements. We are done. Please subscribe our YouTube channel.